So in this video, my goal is to show you 4 different examples of triangles that are given to you where you have to decide if the triangles are congruent to each other, and if they are, by which postulate are they congruent to each other. So if this is the picture, and also I want to let you know that I drew these pictures, so it doesn't look that fancy. It wasn't, it's not like I imported a picture from the internet, so I just drew some of these pictures of triangles. So on the first one, we have these 2 different triangles that are side by side next to each other, and they're in one big triangle, triangle ABC. So when I'm looking at these 2 triangles, the first thing that I'm noticing is the angles that are given that are matching up with each other. So let me write some of these down. So like this angle right here, this angle would be called angle ABD. And because the other angle right next to it, this one, has that same just one arc, that's showing to me that they are congruent to each other. So the other angle that matches up with that would be angle CBD. So we use 3 letters to identify an angle, and that letter in the middle is kind of really telling us which part we're looking at. The other thing that I'm seeing when I look at this picture is the tick marks to show me that the side lengths are the same. So I can see this tick mark right here that is showing me that it's congruent to the other side that also only has 1 tick mark. So what we would say is that line segment AB is congruent to line segment CB. So a line segment is just looking at the length of the side of that triangle. Now, just from what I've listed, that's not enough quite yet to decide if these triangles are congruent to each other by one of the postulates. And let me just list the 5 postulates at the top. Well, I guess I can put them at the bottom. All right, so we have hypotenuse leg. We have side, side, side. We have side, angle, side. We have angle, side, angle. And we have angle, angle, side. Now, if you were to mix up these letters, the S and the A again, you could potentially spell, and I do want to talk about this just for a second. Let's say if I did SSA. Now, this is a way to help you remember that this particular one is not a postulate because it does not work every single time. So we don't use this as one of the postulates. And one way that you could remember that is if you were to spell that backwards, it's a bad word. So that's one way that you can maybe remember that SSA is not going to work as a postulate. Let me get back to the question that we were looking at. So I have information about an angle that is congruent to another one. I have information about 2 sides that are congruent to each other. So let's look at this side BD. If you look at this side, that side is touching on both of the triangles. It's a shared side. So they have to be congruent to each other. So I could say that BD is congruent to BD. And that is called the reflexive property. I'm going to pause and make sure that I spelled that correctly. I did. I spelled it correctly. I'm fantastic. Okay, so now when I'm looking at my triangle, now I have to decide, is there a postulate here that I could use to say that these triangles are congruent to each other? So I'm going to first name these triangles. So I'm going to say triangle ABD is congruent to triangle. Now, when you're naming these triangles, you want to make sure that the letters are matching up correctly. Angle A is matching up with angle C, and then angle B is also matching up with B, and then D is down at the bottom. So you want to make sure that you're writing them correctly. So these triangles would be congruent by which postulate? So what I would do here is I'm going to put this kind of in a thick marker. Let's do this in like an orange color. So what you would do is you would start from one of the vertices, okay? So let's say I'm starting here at A. As I'm going across this triangle, I'm passing across. This tick mark is showing me information about a side. And as I keep going, I go up and I'm getting information. That arc is telling me about an angle. And now I'm going to go back down on the triangle and I'm passing over information about a side. So that is telling me the postulate that I would use here. So these two triangles are congruent by the side angle side postulate. Okay, so let's look at another example. So on this next example, I am going to look at the information that's given, and then I'm going to try to figure out which postulate would match with the picture that we have here. So in the picture, as you can see, we don't have any letters written down, and that's totally fine. We can still come up with a format for looking at which postulate would work. So far I see that I have this angle that is congruent to this other angle, and I know that because we see the arcs. They each have one arc. And then we have the side right here that is congruent to this other side. So what I would do here is I would look at this angle. I'm going to put two arcs right here because I know that that angle might be different from the one arc, so I'm drawing two arcs. So the angles that I just identified here, I know that those are congruent to each other because they are called vertical angles. So whenever we're trying to figure out which postulate to use and the different parts of the triangle that are congruent to other parts, you really have a lot of vocabulary words that you have to be familiar with, especially when you are looking at parallel lines and a transversal. In this picture, we don't know if any of these lines are parallel, only because we don't see arrows indicating that they are parallel to each other. Here, just to go talk a little bit more about what I was talking with parallel lines, seeing that this angle is congruent to this angle is giving me an idea that these two sides are probably parallel to each other because the alternate interior angles are congruent. So, but that's not what this question's asking. I'm trying to figure out which of these postulates would work to prove that these two triangles are congruent to one another. So what I'm going to do is I'm going to get that big orange piece again, and I'm going to figure out which of these are congruent to each other. Try to identify which postulate I would use to show that they're congruent to one another. So I'm going to start at a vertice. Let's say I start right here in the middle. As I'm going this way, I'm looking at the triangle on the right. I'm passing over information about an angle. And then right here on the tick mark, that's showing me a side. And then as I keep going, I end up at another angle. So the postulate here to show that these two triangles are congruent to each other would be angle, side, angle. So that's how I know that these two triangles are congruent to one another. I do want to show you another way to look at this. So I'm going to redraw just one of these triangles because I know that sometimes it's hard to identify which postulate we're looking at. So I just redrew this triangle right here. Okay, so let's say, for instance, that I started right here, and I'm going up this way, and I see, okay, this is information about an angle, and I go here, that's information about a side, and then this is ending with an angle. So really, you should be able to start at any of the vertices to see what you're passing over and what information you can write down to figure out which postulate would work. Let's look at an example here. So on this example, we see just words. There isn't a picture created for us. So what I would suggest that you do is draw yourself a picture to match the information that's been provided. So it says line segment BD is the angle bisector of angle ABC. And line segment BD is the perpendicular bisector of line segment AC. Like I was explaining, a lot of these questions are rich in different vocabulary words. You really need to know what these words mean. So an angle bisector, if we bisect something, that means that we're going to cut it in half. So you're putting it into two equal parts. And in this particular question, it's saying that it's an angle bisector. So we're going to bisect the angle, the measure of the angle. So what I would do is I would start drawing a picture, something like this, because I know I have an angle ABC. Now there's another, there's other ways that you can draw this picture. I'm just showing you one example. So I have this angle ABC and I have a bisector BD. So since B is already that point in the middle of my angle, I'm going to go up to draw point B, or D, I'm sorry. Now we know that line segment BD is also the perpendicular bisector of line segment AC. So I'm going to go right across here and make my picture. So a bisector is cutting it in half, right? So we're cutting in half this line segment AC. That means that this side is equal to this side. And I just realized I forgot to draw that my angles are bisected. So what I'm going to do is put one arc here and one arc here. Those two angles are congruent since they were cut in half. Now, a perpendicular bisector means that we have a 90-degree angle right here. And I want to show you another symbol to show perpendicular. That sign, that symbol, kind of like an upside down T, is showing that line segments are perpendicular to one another. All right, so on this particular question, we have different ways that we could prove that these two triangles are congruent to each other. There's a lot of information that's given here. So let me start by writing some things down. We know that we had an angle bisector, so that meant that angle ABD, which is this, let's do it right here, this angle right here, is congruent to angle CBD, which is right here. Okay, and we know that those are congruent because of the definition of what it means to have an angle bisector. Okay, now the other thing that I could say here is that line segment, oops, sorry, let me put that in blue. Line segment AD is congruent to line segment CD. Okay, and we know that because we had a perpendicular bisector, so that was cutting it in half. And then we can also say that, let's do, we'll do this postulate. So because I have a 90-degree angle, that means the angle adjacent to it, right next to it, would also be 90 degrees. They're supplementary since they're on the same line. So I could say angle ADB, which is this 90-degree angle right here, angle ADB, is congruent to angle CDB, which is this one. They're congruent, they're both 90 degrees, and we got that because we saw that they were perpendicular. Now, let's see, I'm going to use this postulate. So I'm going to use my orange again to outline the triangle. So let's say I'm starting here at angle C, or vertex C. So I'm going across the triangle, and I'm passing over information about a side. So then when I'm going to meet here, I see that 90-degree angle, so that's an angle. And then I go down to outline the triangle, and I'm passing over information again about an angle. So one of the postulates that we could have used here is we could say that triangle ADB is congruent to triangle CDB. And we know that by using the angle side postulate. So there were several other postulates you could have used. So just something that you might have seen. Here we have line segment DB congruent to itself because of the reflexive property. So we could have even used angle side angle. You could have also said that because we have that 90-degree angle, and I know that the two legs are congruent, then that means that the hypotenuse would also have to be congruent on both of the triangles, which is right here. This is the hypotenuse across from the 90-degree angle. And then you could even argue side, side, side. You could do hypotenuse leg. So this one had several different ways that you could go about solving this. Let me do one more example, and then we'll move on. And then I'll be done with this video. So in my picture here, it says, given that line segment SQ and line segment PR bisect each other. So again, this word, bisect, that vocabulary word is telling me that we're cutting it in half. We're cutting these two line segments. They're cutting each other in half. So what that means is right here at this intersection T, that's where I'm getting half of S to T and the other half of Q to T, right? So I know that ST has to be congruent to QT because it was cut in half. And then it's also being cut in half on line segment PR. So I'm going to put 2 tick marks to show that these two sides are equal to each other. So what that means is line segment PT is congruent to line segment RT. All right, now the last thing I could say here is let's look at these angles. Anytime you see angles that are intersecting at this like cross section here, we're going to have vertical angles that are congruent to each other. So what I could say is that angle QTP and angle QTP is this angle right here. This angle is congruent to angle STR, which is this angle right here. Those are congruent because they are vertical angles. So now I have enough information to prove that triangle STR is congruent. And just so you know, you could even put triangle TRS or triangle RST, as long as you're making sure in this congruency statement that when you're referring to the next triangle, you're matching up the letters correctly. So like, for example, STR is passing over the side with the 1 tick mark, going over to the angle. So then I know that I would have to match it up with QTP. So STR matches with QTP. Those two triangles are congruent by, let's look at the postulate. So I'm going to start from one of my vertices. Let's say I'm going this way. Look, I'm not passing over any information at the top. I don't see any information about angle S. I'm going to keep going, and I'm passing over information about a side. Keep going here, and I'm getting information about an angle. Go back up to outline the triangle, and I pass over a side. So that is by the side, angle, side postulate. I really hope that this video was helpful, and maybe hopefully it helps make this concept a little bit less confusing for you guys.